Okay, in this section we're going to be talking about absolute value. So the absolute value of a number x is written like this. It's like two vertical bars, and it represents the distance from x to 0 on a number line. So for example, the absolute value of x equals 4 is asking, right, what numbers are 4 units away from 0? And here's 0. So there's this value that's 4 units away, but there's also this one that's 4 units away. Okay, so if I were to try to solve this equation, the absolute value of x equals 4, my answer would be, well, x equals -4, and also another answer is x equals 4. Okay, because there's two numbers that's 4 units away from 0. Okay, let's add to that. Let's say, what if instead of equals, it was greater than or equal? Well, we know the equal part, this number and this number, but we want to know, okay, what numbers are more than, greater than 4 units away from 0? Well, that's all of these numbers and all of these numbers, right? -5 is more than 4 away from 0. -6 is, -4.2. Also 5, 6, 7, 8. They're more than 4 units away from 0. So if I had an equation that said the absolute value of x is greater than or equal to some number, I'm going to have, look at what this notation tells me. I'm going to have a number that's less than or equal to -4, or greater than or equal to +4. Okay? What if we said instead of less than or equal, instead of greater than or equal, we said less than or equal? Well, once again, we know the equal part. But now if I want the distance to be less than 4 from 0, we're talking about this stuff in between them, right? All of these numbers are less than 4 units from 0. -1, -3.5, less than 4 away from 0. So if I had absolute value of x is less than or equal to some number, any number, my answer is going to look like, oh, it's going to be in between the positive and negative value. All right, so here's the 3 things we've got when we're dealing with absolute value equations and inequalities. If we have an absolute value equation, that means the stuff inside the absolute value bars equals the positive or the negative number of this. Now, this is after we isolate the absolute value bars. We have to have those bars by themselves. So if I had a number out here being multiplied to that, I'd need to divide and get just the bars by themselves. I'm going to have 2 separate equations, one that equals the negative and one that equals the positive of whatever this is. If I have a greater than sign with my absolute value, I'm still going to have 2 separate equations. Okay, one's still going to have the negative. I used 4 up there. One's still going to have the negative, and one's still going to have the positive. Okay, so still 2 separate equations, one with negative or positive, but when I use the negative, I also change that sign. If I'm changing the sign of the number, I change the sign of the inequality. I do it down here too. You just can't tell I did it. Now, if I have a less than with an absolute value, I just have one equation because this is the one that's the and. So I have one equation. I still use the negative and positive of that number, but I put whatever inside the absolute value bars in between them. And we just looked at why. You can back up and look at that again if you need to. And there's a little page there for you that kind of explains what I just explained. So you can read over this if you want to. But let's jump right in and start solving these equations. Okay, first thing I have to notice is what kind of an equation do I have? Remember, that's our first step anytime. And if I have absolute value bars on an x, it's an absolute value equation. Not if I just have absolute value bars on a number. I just evaluate it and go on. But if the variable is inside absolute value bars, it's an absolute value equation. If I have an equal sign, then after I isolate the absolute value, I just put whatever's inside the bars equal to the negative number and equal to the positive value. That's it. And then solve each equation, of course. Okay, so let's add 4 to both sides. So 3x equals negative 7. Divide by 3. X is negative 7/3. Or, let's add 4 to both sides to solve this other equation. So 3x equals 15, divide by 3, x equals 5. Now notice, I always have students that kind of misinterpret, and they solve the equation and then at the end say, oh, it's got to be a plus or minus. But look, that's not my answers. My answer is not plus and minus 5. I have to account for that negative and positive before I start solving. That's the step that allows me to get rid of those bars. Okay, same thing. I say, hey, I've got an absolute value equation. So first of all, it's got to be all by itself. Okay, and then I notice it's an inequality. It's a greater than. Greater than is just like an equal sign. I take whatever's inside the bars and set it to the negative 20, and whatever's inside the bars and set it to the positive 20. Now, if I change the sign of the number, I have to change the sign of the inequality. Right? If I don't change the sign of the number, don't change the sign of the inequality. And then I have two inequalities to solve. So let's subtract 20 from both sides. Negative 2x less than or equal to negative 40. Let's divide by negative 2. Because it's a negative, don't forget, change that sign. Okay, and now let's solve this one. Because I'm dividing by a negative, I got to change that sign. Okay, it's an or. If I need to graph it to help me with that, that's fine. Here's a 0, and let's say here's 20. So greater than or equal to 20, less than or equal to 0. Okay, that means my interval looks like negative infinity to 0 or 20 to infinity. Okay. Absolute value means it has to be all by itself. I got to get rid of this first step before I even think about anything else. Getting rid of those bars. Those bars have to be isolated. Has to be the only thing on that side of the equation. 15 minus 4 is 11. Okay, so it's an equation. So after I get the absolute value bars by themselves, I look right here. That depends on how I set it up. Is it an equal? Is it a greater? Is it a less? Okay, because it's an equal, I just have two equations. One that equals negative 11 and one that equals positive 11. Okay, so 3x equals negative 13, which means x equals negative 13 thirds, or 3x equals 9, so x equals 3. There's no graphing on this. There are two specific values. Oh, two on one page. All right, gotta isolate it. Hey, it's the same thing. All right, so I'm gonna isolate this first so that I have absolute value of x plus 2 is greater than 5. Because it's greater than, I've got two equations. One where I not only change the sign of the number, but I change the sign of the inequality. And the other that looks just like the just like the problem. Just like the problem. Now, okay, that allows me to get rid of the bars. Now I got to solve for x. So x is less than negative 7, or x is greater than 3. Okay. Oh, negative 7 and 3, sorry. So x is less than negative 7 or greater than 3. So my interval looks like negative infinity to negative 7 or 3 to infinity. Now, here's something I think they just want you to know. Okay, just hopefully it'll help with the clarity a little bit. Okay, so I still have x plus 2, except this time less than 5. Because it's a less than, I put this stuff in between the absolute value bars, in between positive and negative 5. Solve this compound inequality. So I have negative 7 less than x less than 3. Notice I got the same values, negative 7 and 3. The only difference is this time, it's the stuff in between negative 7 and 3, right? And if we did the equation where it equals 2, it would be equals negative 7 and equals 3. So I'm going to get the same numerals. It's just which sections of the number line are part of my answer. Okay, got to be isolated. So absolute value of x plus 4, it's, oh, I'm sorry guys, sorry guys, a bird. Ooh, a bird just flew into the window here. Freaked me out. Okay, sorry. Wow, I hope he's okay. Oh, that was awful. Okay, is greater than 3. Because it's a greater than, I just have to memorize. I can kind of think about what that means, right? Oh, greater than a number, it's going to be on the either far end. So that's 2 separate equations, right? It's going to be less than -3 or greater than +3. And then I can solve these individually. So x is less than -7 or x is greater than -1. All right, going that direction and going this direction. So my interval answer is -infinity to -7 or -1 to infinity. Okay, subtract 5 from both sides because I got to get that absolute value bar by itself. And then once it's by itself, whatever sign is here determines how I get rid of those bars. Because it's a less than, I'm going to put that stuff inside the bars in between positive and -3 and solve this compound inequality. So I have 0 is less than 2x. Oh, that one's not 0. So I have -6 is less than 2x is less than 0. So -3 is less than x is less than 0. And because my x is in between these values, anything in between there, my interval is -3 to 0. Okay? Okay. Absolute value has to be by itself. Doesn't matter about anything else right now. It's got to be by itself. Now, once it's by itself, look to see if it's an equal, less, or greater. If it's an equal, I've got 2 equations. One equals the negative, one equals the positive. And then just solve those equations. X equals -5. X equals -3. Isolate it. It being the absolute value bars. Look at the sign to determine how to get rid of the bars. It's a less than, so I'm going to put that stuff inside the absolute value bars in between positive and -8. Okay, solve the compound inequality. All right, so -3/2 and 7/6. Look at this one, guys. Because that number's negative and this one's positive, right? I know the negatives on this side is 0, positives on that side. And my x is in between them with equal signs. So my answer is -3/2 to 6/7. Anything in that interval. Okay. We've done enough of those, hopefully. Now let's talk about something we got to be careful of. They're calling it special cases. So all I'm going to say is remember, the first thing we talked about is absolute value is a distance. So distances cannot be negative. Usually that's the one thing people know about absolute value. If nothing else, oh, it can't be negative. You're right, it can't be negative. So I have to pay attention. Once I isolate that absolute value bar, I cannot let it equal a negative number. And if it equals 0, I have to think about that too. Okay? So, look at these cases. Now, they've got these separated, but I've just got to think about this every single time. Okay? Absolute value equals a negative number. What does that mean? Equals a negative. Absolute value cannot equal a negative number. Anytime I have an absolute value equation that says it equals anything negative, nope, it cannot equal negative. Absolute value is the distance from 0. Distances can't be negative. Now, if I have that it equals 0, it can be 0, right? It can be 0. How far am I from this chair I'm sitting in? 0. So a distance can be 0. But I don't have to have a plus or minus 0. If it equals 0, I can just do the equals 0 and solve that equation. Oh, I could do equals -0, but I'm going to get the same answer both times because -0 and +0 is the same. All right, so this gets rid of my bars. Fraction. Yay, equal sign. Okay, so x minus 12 equals 0. X equals 12. So when our absolute values, after they're isolated, equal a negative number or 0, and we think of those as special, and I just got to think through what it means. All right. What if I had an absolute value that said it was greater than -1? Okay, anytime it's a negative after it's isolated, not before, after it's isolated, I stop and think about it. Okay, doesn't matter about the less than, greater than, or equal to. I think about it. What does that mean? Absolute value is always positive. Always positive. So, what positive numbers are always greater than -1. Always greater than -1. The positive numbers are, okay, well, not to mention the fractions, 0.1, 0.11, right? 1, 2, 3, 4, 5, 6, 7, 8. Everything that's positive is bigger than -1. There's no problem to work out. Don't set two separate problems, right? I just want to think this through. All right, let's do this one. Less than or equal to -1. All right, once I get that isolated, if I still have a negative over here, I got to stop and think, wait, this has to be some kind of positive number. What positive numbers are less than -none? -none. So what positive numbers are less than -1? I think that was a Freudian slip, right? Because none, there are no positive numbers less than any negative. What positive numbers are greater than a negative? All of them. So that's my thought process every single time. What positive numbers are greater than any negative? All of them. What positive numbers are less than any negative? None of them. Okay. Here's where the trickiest of the tricky comes. Okay, if I've got a 0 over here, then the less than goes away, because what positive numbers are less than 0? None of them. But I still have, oh, it could equal 0. So x plus 2 could equal 0, right? Okay, let me know if that doesn't make sense or you have any questions.